The last key feature of rational functions that we're going to look at is holes, or points of removability. Both of them are going to mean the same thing. However, depending on the person that writes the test, writes the question, you may see it referred to as one or the other. So what is it? It is a place on the graph similar to an asymptote, but instead of it being a line, it's nothing more than a point. So how does this occur? Well, it occurs when you have a common factor in numerator and denominator of rational functions. So, for example, if I have x minus 3, x plus 2, all over x plus 2, and then x plus 5. You won't be given pictures or equations or functions that look like this. You'll be given them in more so standard form of top and bottom. So what you need to do is take the top, factor it, take the bottom, factor it. We see that our common factor is x plus 2. Okay. You then figure out what makes this factor equal 0. So x plus 2, set it equal to 0. Subtract 2 from both sides. And you are left with x equals negative 2. From here, to find the rest of your point, you're going to evaluate your remaining piece of the function by plugging in negative 2. So it'll look like negative 2 minus 3 all over negative 2 plus 5. So it'll be negative 5 over 3, or negative 1.66 repeating. So this will be our point of the whole. So if I go to Desmos, I type this in division x minus 3, x plus 2, all over x plus 2, x plus 5, I said we think it occurs at negative 2. I'm going to zoom in a little bit. So negative 2, x equals negative 2. Should be somewhere in here. Now, if I really zoom in, if you put your finger on the function, you see all of these closed dots? Watch what happens as I approach this negative 2. See that? I have a hole. And if you look, where it says -2, undefined, it's an open dot. The reason this is being because at -2, if I were to plug -2 into this down here and evaluate, right? So if I only evaluate the bottom, so right here, and I go -2 plus 2 times -2 plus 5, I really have 0 times 3, which 0 times 3 is then 0, which forces us to divide by 0, and we remember we can't do that. All right. So this is how you get your point. So the point value would have been whole at -2, -1.66 repeating. So continuing on, the one example I've been working through in these last few videos, let's try and factor the top, factor the bottom. So it'll be x plus 5, x minus 1, all over, x plus 4, and then x plus 5. Do I have any common factors? If I do, I'm going to have a whole. If I do not, then I'm not going to have a whole. So I have x plus 5 on top. I have x plus 5 on bottom. So I'm going to say yes at what value? Again, remember, the value is what makes the common factor equal 0. So subtract 5 from both sides. X equals -5. So I have a whole at x equals -5. You then say this point is removable, and what point is removed or taken from the graph? You take the x value you just found for, plug it into, and evaluate what's left. So -5 minus 1 all over -5 plus 4. -5 minus 1 is -6 over -1, which simplifies to 6. So I have a point of removability at -5, 6. So y equals, remember, when you are doing rational functions, always divide, type your top in, make sure you type it correctly, plus 9x plus 20. We said there was a whole at x equals -5, comma 6. So x equals -5. All right, so, and if what I'm doing here is just kind of zooming in so I can see the whole better. That's the only reason I put x equals -5 there. I then click back on my actual rational function, put my finger on it, and then I drag really close to -5. And if you look, it says undefined at this point. And as I'm going up, right? 6.005. Just a little under it, 5.995. So negative 5, comma 6 is a good answer. To finish this up, we talk about domain and range, really mainly just focusing on domain again, hitting it really quick. Domain can be every and all real numbers except for where the breaks in our graphs occur at. So from negative infinity all the way until our first either whole or vertical asymptote. So I have a hole at negative 5. So negative infinity to negative 5. Then from negative 5 to our vertical asymptote, negative 4. Start again, and then from negative 4 to infinity. If it asks us to do range, same deal. Smallest, negative infinity, to our removable point value, or this time horizontal asymptote, whichever is lower. Horizontal asymptote 1 is smaller than 6. So from negative infinity to 1, 1 to 6, and then 6 to infinity. If you notice here, I put parentheses in all of them. That's because these are breaks, holes, or gaps in a graph which cannot be part of the domain or range.